China just built the world's largest ski resort inside a skyscraper. Not beside a mountain, not near one. Inside a single building, rising above one of the hottest, most humid cities on Earth. Qianhai Snow World in Shenzhen will house a ski slope stretching over 1,000 feet long, roughly the length of 3 football fields stacked end to end. You heard that right. 3 football fields of packed snow, suspended inside a glass tower in a city where the temperature rarely drops below 60 degrees Fahrenheit. And what it took to make that possible will change everything you thought you knew about buildings. What is Qianhai Snow World? You've seen indoor ski slopes before. Small ones, tucked inside malls in Dubai or Tokyo novelty attractions where you ride a single lift, do a few runs, and call it a day. Qianhai Snow World is not that. Not even close. What China is building in Shenzhen is something the world has never seen. A single megastructure skyscraper in scale that contains a fully functional alpine ski resort inside its walls. We're talking multiple ski runs, a vertical drop that would embarrass most regional ski mountains, a gondola system running through the interior of the building, and enough snowpack to keep hundreds of skiers moving simultaneously. All of it sealed inside climate-controlled walls while the subtropical city outside bakes in the heat. The complex sits in the Qianhai district, Shenzhen's most ambitious urban development zone, a place already known for pushing the boundaries of what a modern city can look like. Qianhai Snow World is designed to anchor that district as a global landmark. The numbers are staggering. The total development spans millions of square feet. The ski slope alone stretches over 1,000 feet in length. The building rises high enough that from the outside, it reads as a tower, not a ski resort. But here's what makes this different from every other indoor ski facility ever attempted. Every other project was built low and wide, a warehouse logic, spreading out horizontally to fit a slope inside. Qianhai Snow World goes vertical. The slope doesn't sit at ground level. It travels through the building, rising and descending through multiple floors, using the building's full height as the mountain itself. That single design decision changes everything about how the engineering works and everything about the challenge of keeping it frozen. This isn't just a ski resort that happens to have a roof. It's a skyscraper that happens to contain a mountain, and the gap between those two things is where all the hardest engineering lives. But before you understand how they built it, you need to understand why Shenzhen was the city that decided to try. Shenzhen's grand ambition. Shenzhen doesn't do things quietly. This is a city that went from a fishing village to a metropolis of over 17 million people in roughly 40 years, a pace of urban growth that has no parallel in human history. So when Shenzhen decides to build something, it tends to be the kind of thing that makes the rest of the world stop and stare. Qianhai Snow World didn't happen by accident. It was a strategic decision, rooted in a specific vision for what Shenzhen wants to become next. The city has already won the manufacturing game. It already dominates tech hardware. Now it's chasing something harder to manufacture: desirability. The kind of city people fly to, not just fly through. And a ski resort inside a skyscraper visible from the highway, impossible to ignore, is exactly the kind of landmark that puts a city on a different map. The Qianhai Special Economic Zone is the vehicle for that ambition. It's a district designed from the ground up to attract international business, high-end tourism, and the kind of investment that follows spectacle. Qianhai Snow World is the anchor project, the thing that makes the whole district feel like the future has already arrived. But there's a larger context here that makes this even more significant. China has been building indoor ski resorts at a pace no other country can match. Over the past decade, dozens of facilities have opened across the country, driven by a government push to grow winter sports culture ahead of the Beijing Winter Olympics. That push created an entire industry, engineers, contractors, and refrigeration specialists who now know how to build snow indoors better than anyone else on Earth. Qianhai Snow World is what happens when that expertise meets unlimited ambition and a city with something to prove. It's not just the biggest indoor ski resort China has ever built. It's the biggest statement China has ever made about what a building can be. But ambition alone doesn't keep snow frozen in 30-degree heat. And that's where the real problem begins. The freezing problem. Imagine trying to keep an ice cube from melting not in your hand, not on a countertop, but in the middle of a sauna. Now scale that up by a factor of several million. Add hundreds of tons of packed snow and place it inside a glass tower in one of the most humid cities in Asia. That is the baseline engineering challenge of Qianhai Snow World, and it doesn't let up for a single second. Shenzhen sits in the Pearl River Delta, just above the tropics. Average summer temperatures hover around 90 degrees Fahrenheit. Humidity regularly pushes past 80%. The city sees intense subtropical heat for most of the year, with brief, mild winters that still never come close to freezing. In other words, the natural environment is the single most hostile possible setting for a ski resort. Every element of the climate, the heat, the moisture, the air pressure differentials, is working against the project at all times. This is what engineers call thermal load, the constant pressure of warm energy pushing inward against a cold environment. In a standard building, you manage thermal load with insulation and HVAC. In Qianhai Snow World, the thermal load is so extreme that it requires an entirely different category of engineering response. The temperature differential between the inside of the ski slope and the outside air can exceed 100 degrees Fahrenheit on a hot summer day. Maintaining that gap continuously across a structure the size of a skyscraper is an energy and engineering challenge with very few precedents on Earth. And it's not just the heat. Humidity is its own war. Warm, moist, subtropical air carries enormous amounts of water vapor. When that air contacts a sub-zero surface, it doesn't just warm it, it releases moisture, forming ice in the wrong places, degrading snow quality, and threatening the structural integrity of insulated surfaces over time. Every crack in the building envelope, every poorly sealed door, every moment of exposure is a vector for warm air to assault the interior. This was just the beginning of the problem the engineers had to solve: the refrigeration system. To keep a ski slope frozen inside a subtropical skyscraper, you don't just turn up the air conditioning. What Qianhai Snow World requires is a refrigeration system on an industrial scale, the kind of infrastructure more commonly associated with massive cold storage facilities or large-scale chemical plants than with a building. People ski inside. The core of the system is a network of chiller units, machines that work like oversized refrigerators, extracting heat from a coolant fluid and circulating that fluid through the building at sub-zero temperatures. But the scale here is unlike anything in a conventional building. The chillers required for a project like this rank among the largest deployed in any single structure, running continuously, around the clock, every day of the year, regardless of season. That coolant doesn't just pump through mechanical rooms and ceiling ducts. It runs through pipes embedded directly in the floors and walls of the ski slope itself. The snow sits on a surface that is actively being refrigerated from below the floor, acts as a giant cooling panel, maintaining the snowpack temperature from the ground up. The walls contribute the same way, pushing cold inward from every surface. The result is a fully three-dimensional cold environment, not just cold air blown from above. Managing the energy demand of this system is its own engineering discipline. The refrigeration load at Qianhai Snow World is immense, the kind of power draw that requires dedicated electrical infrastructure and sophisticated load balancing strategies to prevent the system from overwhelming the local grid. Engineers have designed the operation to shift its heaviest cooling cycles to off-peak hours where possible, using thermal mass, the cold stored in the snow, and structure itself as a buffer during peak demand periods. What makes this especially brutal is that the system never gets a break. Unlike a ski resort that closes in summer, Qianhai Snow World is designed to operate year-round. The refrigeration infrastructure has to fight Shenzhen's worst heat day after day with no seasonal reprieve. But keeping the air cold is only part of what it takes to make a ski slope real. Snow and climate control. Cold air alone doesn't make a ski slope. You need snow, real, skiable, compactable snow. And inside a sealed building in a subtropical city, that snow has to be manufactured from scratch, managed constantly, and defended against the single biggest threat an indoor ski environment faces: moisture. The snow guns used inside Qianhai Snow World work on the same basic principle as outdoor snowmaking systems. Pressurized water is mixed with compressed air and ejected through a nozzle at high velocity, where it atomizes into tiny droplets that freeze before they hit the ground. But indoors, the parameters have to be dialed in with far greater precision. The temperature, humidity, and airflow inside the building directly affect how the snow forms, how dense it lands, and how long it holds its structure underfoot. Too much moisture in the air, and the snow becomes wet and heavy. Too little, and it turns brittle. The snowmaking system has to read the interior environment in real time and adjust constantly. Once the snow is down, it has to be groomed. Machines scaled and adapted to work inside the building's constrained spaces, pack and shape the slope surface on a regular cycle, maintaining the kind of consistent, even surface that skiers expect. Managing the snowpack depth, replacing degraded snow, and redistributing accumulation across the slope is an ongoing operational challenge that runs parallel to all the mechanical systems underneath. But the deeper battle is humidity. This is where the climate control system earns its complexity. Shenzhen's air carries enormous moisture loads, and every time a door opens, every time a warm body enters the slope, every time equipment moves between zones, water vapor enters the cold environment. Left unchecked, that moisture condenses on cold surfaces, degrades insulation, and corrupts the snow. The dehumidification system running alongside the refrigeration infrastructure strips moisture from the interior air, continuously processing massive air volumes to keep humidity levels within the narrow band that allows the snow to behave like real alpine snow. The building itself is engineered as the last line of defense, a sealed envelope designed to keep the outside world out. The building envelope. You've seen how the refrigeration system fights the heat from the inside. But here's what most people never think about. None of that machinery matters if the building itself lets the outside world in. The real silent hero of Qianhai Snow World isn't the chillers or the snow guns. It's the skin of the building. And it had to be engineered like nothing ever built before. Think of a standard skyscraper. Glass curtain walls, steel frames, conventional insulation. That building is designed to moderate temperature to keep out wind and rain while allowing natural light in. Qianhai Snow World has an entirely different mandate. Its envelope has to function as a thermos, a continuous, unbroken barrier that seals a sub-zero environment inside a structure exposed to subtropical heat on every surface, every hour of every day. The panels used to construct the thermal envelope are high-performance composite systems, multiple layers of insulating material bonded together to achieve thermal resistance values far beyond what any conventional building requires. Where a standard wall might have an insulation rating designed to handle a 20-degree Fahrenheit temperature differential, the envelope here has to hold against differentials exceeding 100 degrees. Every panel joint, every structural penetration, every mechanical entry point is a potential thermal bridge, a pathway for heat to bypass the insulation and bleed into the cold zone. Every single one of those points had to be sealed with thermal break materials that interrupt the conductive path between the warm exterior and the cold interior. The vapor barrier layer is equally critical. At sub-zero temperatures, any moisture that penetrates the envelope doesn't just warm the interior, it freezes inside the wall assembly itself, expanding, cracking insulation, and progressively destroying the barrier it was meant to protect. The vapor control system has to stop moisture migration before it ever reaches the cold side of the wall. But keeping the building sealed is only the beginning of the structural challenge. Because the real question was never just how to insulate the slope, it was how to hold it up. Engineering the slope. You already know the building is massive, but here's what doesn't hit you until you really think about it. The ski slope inside Qianhai Snow World isn't sitting on solid ground. It's suspended inside a vertical structure, elevated above the city, supported by a building frame that had to be engineered from scratch to carry a load profile no skyscraper has ever been asked to hold before. Snow is heavy. Packed, groomed alpine snow weighs anywhere from 20 to 30 pounds per cubic foot. Multiply that across a slope stretching over 1,000 feet in length. Factor in the weight of the grooming equipment, the lift infrastructure, and hundreds of skiers moving simultaneously, and you're looking at a structural load that dwarfs what a conventional high-rise is designed to carry. The engineering team couldn't simply adapt a standard skyscraper frame. They had to design something new. The structural solution involves a series of massive transfer floors, reinforced horizontal planes built into the building at key intervals that redistribute the slope's weight outward into the primary load bearing. Columns. Think of it as a series of hidden bridges inside the building, each one catching the weight of the snow above it and routing that force down through the frame in a way the foundation can absorb. The columns themselves are deeper and more closely spaced than in a conventional tower, and the foundation work required to anchor this structure in Shenzhen's Pearl River Delta soil conditions pushed geotechnical engineering to its limits. Then there's the slope geometry itself. A ski run needs a consistent grade steep enough to be exciting, shallow enough to be controllable, with transitions between sections that feel natural under skis. Designing that geometry inside a building that also has to function as a commercial tower required the kind of three-dimensional spatial planning that pushes architectural software to its boundaries. The slope doesn't run in a straight line. It bends, transitions, and navigates around the building's structural core. But moving skiers up that slope required solving an entirely different kind of engineering problem. Lifts inside a skyscraper. Getting down a ski slope is the easy part. Getting back up is where the engineering gets interesting. And inside a sealed skyscraper, the solution to that problem looks unlike anything you'd find on a conventional mountain. Traditional ski lifts are designed for open air. Chairlifts, gondolas, surface tows, they all assume exposure to the outside environment. Natural light, open sightlines. None of those assumptions hold inside Qianhai Snow World. Every lift system in the building had to be reimagined for an enclosed, climate-controlled environment where the ceiling is a structural floor. The walls are insulated panels, and the available space is precisely defined by the building's geometry. The gondola systems inside the complex run through enclosed shafts within the building, essentially ski lifts operating inside elevator-like corridors, moving skiers from lower slope levels to upper departure points through the building's interior volume. The engineering challenge here is significant. Lift cables generate heat through friction. The motors that drive them generate even more. Inside a building fighting to maintain sub-zero temperatures, every heat-generating system is a threat to the climate envelope. And the lift infrastructure had to be designed with thermal isolation in mind, separating mechanical heat sources from the cold zones through insulated barriers and dedicated ventilation channels. Skier flow management adds another layer of complexity. On an outdoor mountain, crowds naturally disperse across open terrain. Inside a building, every skier is moving through defined corridors, loading zones, and transition spaces. The lift system has to meter that flow, precisely controlling how many people enter the slope at any given time, managing queue dynamics in enclosed spaces, and ensuring that the constant opening and closing of loading doors doesn't compromise the interior climate. Safety systems inside an enclosed ski environment are more demanding than anything on an outdoor mountain. Emergency egress, fire suppression compatible with sub-zero temperatures, lift evacuation procedures inside a sealed building. Every scenario had to be engineered specifically for this environment. And beyond the slope itself, the building had to function as something far larger than a ski resort. A city inside a building. Step back from the slope for a moment and look at the full picture. Qianhai Snow World isn't just a ski resort with a building around it. It's a complete urban environment retail. Hotels, restaurants, entertainment venues, and a ski mountain, all operating simultaneously inside a single structure. The engineering challenge of keeping the slope frozen is only one layer of a far more complex problem, making all of it work together. The thermal separation between the ski zones and the rest of the complex is one of the most sophisticated aspects of the entire project. The retail floors, hotel rooms, and dining spaces operate at normal temperatures, comfortable, climate-controlled in the conventional sense, but they share walls, floors, and ceilings with zones that are being held at sub-zero temperatures. Every boundary between those environments is a thermal battleground, and the building's engineering team had to design transition systems, airlocks, insulated buffer corridors, thermally broken structural connections that prevent the cold from bleeding into the warm zones and the heat from invading the slope. What makes this remarkable from a visitor experience standpoint is how seamless it's designed to feel. You walk through a shopping concourse, pass through a transition zone, and step onto a ski slope without ever leaving the building. The spatial choreography required to make that transition feel natural rather than industrial pushed the architectural and interior design teams as hard as the engineers. The goal was an experience where the contrast between environments feels magical rather than mechanical. The hotels inside the complex occupy upper floors with sightlines directly into the ski slope rooms where you can watch skiers move through the building below you while sitting in a warm, comfortable space. That integration of spectacle into the hospitality experience is deliberate, and it required structural planning that treated the ski slope as a visual centerpiece of the entire complex, not just a functional amenity. This is what sets Qianhai Snow World apart from every other megaproject on Earth. And what it points toward is something even bigger, a new frontier in architecture. You follow the engineering from the refrigeration pipes in the floor all the way to the gondolas running through the building's interior. You've seen how humidity is stripped from the air, how snow is manufactured and managed, how a structural frame was reinvented to carry loads no skyscraper was ever meant to hold. And now you're standing at the top of that slope, inside a building, above a city that is baking in subtropical heat outside these walls. What Qianhai Snow World proves definitively, at full scale, is that humanity can now recreate outdoor environments inside buildings with enough fidelity that the distinction between inside and outside starts to blur. Not as a novelty, not as a scaled-down simulation, as a fully functional, commercially operational environment that delivers the real thing, real snow, real vertical drop, real alpine conditions inside a climate-controlled megastructure rising above an urban skyline. The precedent this sets is staggering. If you can recreate a ski mountain inside a skyscraper in Shenzhen, the engineering logic that makes that possible can be applied to other environments. Rainforests, beaches, desert canyons. The technical barriers that once made outdoor environments irreplaceable are falling, one refrigeration system and one dehumidification network at a time. Qianhai Snow World isn't the end of that story. It's the proof of concept that opens the door to all of it. But here's the moment that makes everything land. You push off from the top of the slope. The cold hits your face. The snow compresses under your skis exactly the way it would on a mountain in the Alps or the Rockies. Below you, through the glass walls of the building, you can see Shenzhen's skyline stretching to the horizon, towers, highways, 17 million people living in subtropical heat. And you are skiing inside one of those towers, in the middle of that city, in conditions that took an army of engineers, an unprecedented refrigeration infrastructure, and one of the most complex buildings ever constructed to create. China didn't just build the world's largest indoor ski resort. It proved that the mountain can come to the city and it can be better than the real thing.